Hello and welcome back to Calculus 2. Today is the review day. We are going to put chapter 6 in perspective and then also talk about integration in addition to that. Exam is next Tuesday. Hope we'll all show. I said this and it's going live now and you can always fall back onto it. Even the hand-delivered note from God will not get you off from that test. You picked the date, that is it. Make sure you don't engage in any, dangerous activities over the weekend, because if you break your right arm and that's the arm you write with, you have like 2 days to figure out how to write with the left. Broken legs and stuff, have someone wheel you in, carry you in, or whatever else. Technically stay away from death and diseases and extreme sport.
You look at
it. From beyond. It's, the committee is called Calculus and Beyond, so, and I'm the chair of that committee, so there you go. All right, so I would say 10 questions standard. If we have one or two spicy questions, there might be a replacement question. So all the good stuff I talked about last class. Today we're just going to do the serious work for at least 5 minutes. And we'll see lab 1, hopefully due on Tuesday. Hopefully you can put that final report today and you have the 5 problems that you did on the software ready to attach to this lab. No individual labs. You all need to be in a group, at least 3. 3 to 6, let's say. But if you have a group of 24, I mean, what can I do? I can split it in 8 groups of 3. Yeah. Any kind of general questions, concerns? Just questions. No. Yes?
How do we do the Mathematica, remember how the syllabus link didn't go to the Mathematica? So yeah. I was thinking,
there was supposed to be
some... do the Mathematica today, but I just realized that there's no computers in the studio.
Yeah. All right. I'll fish for it. I'll fish for it. Chapter 6. Are you excited? That's the spirit, okay? So, I'm not even going to talk about 7.1 because it's just integrals, right? So, every single formula is the integral of some sort. So, we start with area between 2 curves. Looking at that, a equals integral a to b of f of x minus g of x dx. That's top minus bottom, or you can have dy, which would be right minus left. Does that make sense? Good, you remember that formula. Then we have the disk method. Again, can be dx or dy. A is equal to pi integral a to b. It was f of x squared dx. But then we had the washer method, which was better. And it was f squared of x minus g squared of x in parentheses times dx. Now we can have each one of these in terms of y, c to d, and then function in terms of y. Yeah, you'll have to swap the function depending on what's given to you. So for both of these, this is rotation around x. And then if you have rotation around y, it will be dy. And then you have the one that it's different, right? Shell method. which cuts off those shells. Oh my God, these are not areas, these are volumes. I know. Luckily, tablet didn't explode. So we said 2 pi a to b p of x h of x dx, and this was rotation around y. So now we see that when we use dx, rotation is around y. If you are to have rotation around y, around x, then the integral would be dy. So that's what we have. And then after the shell method, we went and calculated the arc length area, the length of the curve. Which was the one-dimensional L equals integral a to b of the square root of 1 plus f prime squared of x dx. And I'm just going to put over here in parentheses the trick. So remember that manipulation that we did with the half and the plus 1. You can probably look in one of the problems later. After this was surface area of revolution. And that would be, again, its area integral. We have the 2 pi integral a to b, and we have the f of x times the square root of 1 plus f prime squared dx with rotation around x. Then we have a section on physics, where I told you that if the problems from this section show up, I will give you the formula for it. But again, there is that portion where you struggle and suffer through geometry, and you need to know what plugs where, even if you have the formula. So don't just skip it because the formula is given. You got to know how to use it, right? You don't have to make the hammer, but you need to know how to use it, all right? After that, two sections on 6.8 and 6.9 on E's and ln's. So we had 6.8 was more of the definitions of E and so on. So no definitions from 6.8. And then we have the word problems. I'll just say word problems plus calculus. And finally, hyperbolic. No, word problems from 6.9. Work is in physics. And then last section, 6.10, hyperbolic functions. Now, for hyperbolic functions, must know what? You must know that sine hyperbolic x is e to the x minus e to the minus x over 2. And cosine hyperbolic x is equal to e to the x plus e to the minus x over 2. And then, I'll put little stars here. Use those to prove given identities. So I will ask you to prove, I don't know, sine of x plus y, sine hyperbolic x plus y, or something like that. And then at the end there is 7.1, but guys, 7.1 is just a review of everything you learned so far: substitution, back substitution, splitting the fractions, and then we also had multiplying by 1 and something else. Dividing polynomials. There we go. Cool. So this is the exam. So how many formulas? Is that 8 formulas? Yeah, that's 8 formulas. Well, the 6 up top, I also have the y counterparts, so that's technically 14 formulas if you want to count each one of those. Yes?
Why do you do a trick next to arc line?
Trick. It's that when we're solving it, you have to remember that trick was 1 plus, and then you had the parentheses squared, we expanded, and then added half and the 1, which changed the sign, and then we condensed it back to kill the square root. It was a trick calculation right here. This one. So when you plug everything in, which is the first pink underlining, you expand, which is the second one, and then you see that you have 1 in front and negative 1/2. It creates a positive 1/2. So if the negative came from here, these two are the same, it just has a positive there, then this and this has to be the same with a positive. So that was the trick.
Where did the 1/2 go?
Added them together. 1 minus a half is a plus half.
Where does it go after that? I know that. I see that.
Well, when you factor it in, right? It
Goes back
absorbs. Yeah, because when you expand this, you get it. If you are to condense it, it goes into this.
Do we have to show the steps in between with the trick?
No, but you know, what happens if it's not a trick? Exactly. Sure. I just explained it.
No, I'm still not.
If this little square expands into this, then the green thing condenses into this. Because this and this is the same except this sign, and this is the same except this sign.
But you can keep the one and add it later, right?
When you do that trick, you just like take the derivative, use of it, derivative, and then just solve it like that. Or
Nope.
you can't. You have to know that trick.
This is it.
Why is it switch signs?
1 minus a half is positive half. That's how awesome this stuff is. And then this trick also propagates to surface area of revolution. Who's in? All right. So we're going to start with the iPhone question.
That's 7 equations. I only have 6 here.
I said 8. There are these 2.
Oh yeah.
And then 6 up there.
I didn't cut those.
Now those 6 all have y equations as well, so it's technically double. Nina, what's the problem?
Find the area of the following region. Region bounded by y equals e to the x and y equals 12 e to the minus x plus 4 and x equals 0.
Is this plus 4 in the exponent or the way I have it? Awesome. All we need to do is to graph this and then just integrate, and that's it. And it's ease, which means it's going to be easy. So this be e to the x. And then I have plus 4. So 1, 2, 3, 4. This is where the horizontal asymptote moves. That's where the horizontal asymptote is. And I need e to the negative x, and then it needs to be 12 times, so it's going to look like this, something like that. And they say x equals 0, which is this line here. So this is the shape. So if you look carefully, this is the only shape that is bounded from all three sides. There's a function on top, function on the side, function on the left, right and the right. So now I'm going to ask myself if this is the area between two curves. So I either set up dy or dx integral, right? I have to set up one of those two. So I ask myself, what's the better one, dx or dy? If I look at the representative rectangle dx, I see that the top always slides on the top function and the bottom always slides on the e to the x function. Therefore, that's a good choice. If I'm to choose on a shape that looks like this, if I'm to choose dy, dy is fine, but dy over here is a different integral, because over here you have a function 1, over here you have a function 2. So at this point, when you start working on integral, you'll have to cut at that point and then have two separate integrals, c to d and again c to d, for different values obviously and different functions to compute this. So it's much more work to do dy. We're not going to do dy, we're going to do dx. So I have the dx set up, and immediately I can see that it's, oh, I need limits. Hold on, comments. So area is going to be integral. We'll populate the limits. We have the top function, which is 12e to the minus x plus 4 squared. No squared. This is just a basic subtraction. So yeah, we can integrate, but we don't have those limits. So let's first find the limits. It's going to be e to the x is equal to 12e to the minus x plus 4. And now what? We multiply everywhere by e to the x. And we get e to the 2x minus 4e to the x minus 12 equal to 0. I hope I did this right. Is this good? Because e to the minus x and e to the x will cancel. That leaves just the 12. And then, all right, it sounds good. So this is equivalent to having a problem u squared minus 4u minus 12 equal to 0. Do we have factors of 12 which would add to negative 4? And the answer is obviously sure, which is what? 6 and 2. Nice. Yeah, that's what I said, positive 2. And now we have e to the x equals to 6 and e to the x equals negative 2. Now e to the x cannot equal negative 2 because e to the x graph is entirely above x-axis and negative 2 is below. So we only get to solve the first one for x, which is ln 6 in this case. And we have that the left limit is 0, 0 to ln 6. So all we need to do, dare I say, is to integrate. So what am I integrating? I'm integrating 12e to the minus x minus 4 minus e to the x dx. So what now? What's the integral of 12e to the minus x? Very good. Minus 4x minus e to the x from 0 to ln 6. Now, if this negative 12 bothers you, it's going to be negative 12 over e to the x. And now when you... Where? In the problem statement of the problem?
Yeah.
That's what I thought. Scroll up? Yeah, I can.
Yeah, so I have a question there. Like, when you take the limit from d to dx equals to 12.
Limits?
Yeah, but when we have to find the...
Oh, the limits of integration. Sure.
Yeah. So, can you just take ln on both sides? Like, you multiply...
Here?
Yeah.
You can't, because it's going to be ln of 12 over e to the x plus 4. And there's no formula to break addition under log. There is multiplication within the log goes as addition of 2 logs. But there's nothing for ln of x plus y. You have sine of x plus y develop and cosine of x plus y develop into something. Ln of x plus y does not. It's ln x times y that gives you ln plus ln. So it doesn't work the other way. All right. And this problem is done, right? So what do I have? When I plug in ln x, this is over e to the x, so that's 6, so negative 12, so negative 2. Plus 4 ln x, sorry, ln 6, minus 6. Plug in 0, so plus 12. Plug in 0, dead, and minus plus 1. So that's what? Positive 6, positive 4, positive 5. This is good. That's the answer? The almighty MyMATLAB review. Happy?
Yeah. I just in the quiz, I didn't know which like form they wanted in, so instead of ln6, I wrote 1.79. So they said wrong. Yeah, but I still got 72, so I was like, I'm not gonna redo it because I know it. I guess.
72. That counts.
Because I did it right, it was just the form.
From this point on, if you guys have any questions, any problems that you would like me to see work on, sure. If there are no further questions, you can just work on the lab.
This was something stupid.
Awesome.
That's all you probably want. At the very top.
But what is supposed to happen?
This method.
This use the disk method, and that's the information gathering.
Use the disk method and then information rotates on which axis?
Is it on there? I think X.
X-axis.
It's not on. Okay.
Well, I use the X. X.
Well,
No.
Yeah.
that's an 11, yes. Two vertical bars.
Yeah, but the thing right next to it is two horizontal lines next to each other like that. Is that sideways 11?
Yes. Yes, so you have y equals, no, y sideways 11, upright 11, and then sine x. Very good, very good.
And because two perpendicular lines, they make a plus sign, that's y plus sine x. There you go.
Yeah, technically, when you combine them, you get a number when you overlay them.
Yeah.
I see. Okay, got it. All right, so work on this for about 23 seconds. At least set it up. It's a disk method. Right? They want the disk method. Rotation is on x-axis. The function is equal to x. So it's technically minimal work. You just, it's plug and chug. Yeah, Bob.
In terms of the shell method, when you say p of x, is that the position of the axis of rotation?
Yeah, y is equal to y.
P of x, y of x, right?
H of x.
H of x, yes. So h is the height of the function. So it's that here.
And then p of x position.
Usually x. Yes.
But if it was like shift, it would be like
200. I want to know how freaked out you are regarding this exam. Like on a scale of 3.8 to like 7.6. 7.6.
I mean, it can't be, 3.8 is too much, but it's
Professor, that 11,
Yeah, or whatever you want to do.
He didn't hear the conversation about how it's up.
No. It's y, sideways 11, upright 11, sine x. Oh. Why is blind to the problem?
Don't lick around.
We'll compare it all.
I have no idea. I see something else like yesterday.
What I did yesterday was pull it up.
Oh, I
That's
took
my road.
Make
Oh,
what did you do?
I would say,
Yes, I split it up because then
I can set it up and then leave it like that.
it's 2x.
I think we're gonna use the double angle.
See, you know.
Uh,
Show everyone how it's done. Here's like,
I just know how to set it up.
what?
I don't know how to integrate the double angle
Why?
formula. I don't know. I got confused there.
Wait, you want to tell me that you don't know the formula?
No, I know the formula.
So why don't you use it?
Just integrating it. Oh, that's sorry.
Okay.
And then,
Limits?
oh, Oh, limit is 0.
All right, guys, so we have the setup. The integral is set up. That's it. Now, we have 11 squared. That goes in front of the integral. We don't care about that.
Wait, what was it?
11 squared.
Oh.
So next step.
The next step is going to be pi, and then limit squared is 100.
No, just put 11 squared.
And then sine squared x. And then you want to write this.
Oh, dx.
Oh, dx. And then this, and then write it
Oh, you know the formula?
I know the formula.
All right, there it is. So you have to know the double angle formula for sine and cosine. Otherwise, these things are not going to go well. There it is, and that's it. So that's the solution. Well, no, I mean you can still integrate.
That's what I wanted.
Oh, the arithmetic is the problem. Sure. Okay. All right. The what? They want the final answer at the problem, and then that's when it explodes. Let's take a look at it together then. So we have the we will kick 11 squared pi outside 0 to pi, and then we have sine squared x dx. We use the formula 11 squared pi integral 0 to pi 1 minus cosine 2x over 2 dx. And this is the one that actually splits, right? You have a fraction, but you don't actually have to split it because over 2, you kick that outside. It's a constant. So 11 squared pi over 2 goes outside, and all you need to integrate is 1 minus cosine 2x dx from 0 to pi. Now, if you want this, you want 21 pi over 2 if 11 squared is bothering you. The integral inside is x minus, integral of cosine is positive sine, so we have sine 2x divided by 2, everything computed from 0 to pi. Now the beautiful thing is that both sine 2x is 0 for 0 and pi, x is for 0, so you have 121 pi squared over 2, or if you want to be fancy, 11 pi everything squared over 2, 1/2 11 pi squared. Those are all different possible answers for it. I think that's it. There's nothing else. So let me check one more time. The double angle for the power reducing formula goes here. This 2 goes outside, which is right there. 1 minus cosine. Integral of 1 is x. Integral of cosine is sine, but it's over 2 because of that 2. It's over 2. When you plug in pi in x, it survives. When you plug in pi, sine of 2 pi is 0. It dies. Over 2 is also. Plug in 0, it's gone. Plug in 0, it's gone. So all of them are gone other than the pi in this x. So that's pi times pi, pi squared. So if you plug it in this way, it should take it. It should take it this way. 121 pi squared over 2. Yeah.
Are we going to remember the test, the power reducing formula?
The answer is hell yes. And also 7.3, 7.4 coming up in the next will all feature that formula. Those two formulas are must. What are the other cool formulas that you should know? Double angle, so sine 2x is equal to 2 sine x cosine x. Cosine 2x is cosine squared minus sine squared, or other iterations of that. Pythagorean identity, sine squared plus cosine squared equals 1. Those formulas from trig are necessary for this class. You need to know these.
Half angle, double angle, and
What chapter is parallel formulas from?
Yeah, they are in, I believe they are in 5 point something in Calculus 2. 5.3, something like that. Yeah.
So what are the most important ones? Yeah.
For the test, these two. So for the exam, this stuff will pop up many times. Not necessarily all of these on this test, but across the board for Calc 2. So we have power reducing sine squared x is equal to 1 plus, 1 minus cosine 2x over 2. Cosine squared x is equal to 1 plus cosine 2x over 2. Sine of 2x is equal to 2 sine x cosine x. That pops up. And then cosine 2x is cosine squared x minus sine squared x. Now you can write sine as 1 minus the cosine, right? So it's going to be also 2 cosine squared x minus 1 or 2 or 1 minus sine 2 squared, yeah. Those are all other iterations by simply using Pythagorean identity. Oh, and Pythagorean identity, holy. So for upcoming exam, these two, for the sake of other exams and the final, all 5. And those are just basic trig identities. You know that there is a whole chapter of that stuff. Cool questions.
did you?
Nah.
But those two.
We'll keep it like 15%.
Those
Because we got to put in some ease.
Did you already like review the exam?
Tuesday. What do you think I am? Yes.
So I get that we don't need to know all those, but the 2 circled in blood, those are the ones. Those are the ones we need for the exam. The rest of them we don't have to worry about yet.
Yeah, but 7.3 and 7.4 or something.
Okay.
The winter is coming.
I'll do that next time one.
Some of like Europe.
No, he just that was just absolutely amazing. This is what you know with the 2 nerds connected. All right.
So is that extra credit?
Any other questions? Yes.
Can you go over use of stuff? Because I know there's that thing where like you can change the upper and lower limits depending on the U. And I was trying to teach him it, and then I remembered I also don't know how to do it either.
So keep trying to teach and you will learn.
Can we do the ones where you put trig in parentheses? Can we do an example?
But I put trig in
Of the arc
parentheses.
length? Trig.
Trig.
The one you said trick.
Oh, I heard trig.
No trig.
And that's because someone suggested.
I suck at asking questions.
Yeah, I can try. No. So we have 2 problems to work on, and I could actually put them in the same problem, but then no. Let's do 2 separate examples. What else I want to do? How's this?
So do you think if we do the examples given in class, then we'll get the...
No.
Not the...
Nope.
drop them
What would
into your standard time.
what
What
would
was the
help?
level? You said like it was homework, then labs, and tests, and quizzes or something.
Like
Or
it's
the
No.
level of
I
difficulty.
still think that like
There's
I think you dropped something.
homework,
Your standard
exam,
time.
lab,
That's like
and then the project.
But homework would be
Hey, I lost my number.
Yeah, should be.
I also lost my phone and my wallet. This is a robbery.
there's gonna be 10 questions instead.
Yes, unless you are petitioning for 50,
No.
which
What would help us actually like prepare us? The quizzes online.
yeah, online quizzes every day, and then you just do other 150 examples a day from the book and
Not from the
yeah.
notes we took.
Yeah, well, some of you are still trying to figure out where the stuff is and asking me, crying out the homework and so on. Give me a second. So, guys, just want to go quick. So, when you are in my math lab, and this is Calculus 2 class, so you click on Calculus 2. Should be the only one you have, actually. So when you go into Calculus 2 class and the homework is closed because of the deadlines and you want to practice, you have 3 different outlets before the test. One of them is quizzes. Under quizzes over here, right? And as you can see, I missed the first quiz, which is the reason why I do Calc 2 every semester. I keep coming back to it because it just doesn't work for me. So you have these daily quizzes, and then you have these tests. The smartest thing you can do, tomorrow is Friday all day, right? The smartest thing you can spend your time on tomorrow is to take this Chapter 6 post-test. It doesn't count towards the homework grade, it doesn't count towards the quiz grade, nothing. It doesn't count at all. But it will have questions on Chapter 6, and it's the test environment. And if you are smart enough to actually do that without notes, without others, Mathematica and so on, you sit with a solar calculator and then some paper, and you work it out in peace. That will tell you the grade at the end. It will tell you that you scored 78 or 28. And then you will know where you actually stand 5 days before the exam. And you have 5 days to fix the area where you have issues. If you don't do that, and you go and you do your quizzes, and each quiz takes you 2 hours because you are scrolling, right? Well, you're scrolling through my notes, or you're going through your notebook looking for a similar example to do monkey sees, monkey do. You just don't know the concept because clearly you're not able to do the problem on your own. Yes, you are passing the quiz, gives you a point, but then remember that there are 100 points available on the exam where scrolling and browsing through notebooks and textbooks is not available. So don't kid yourself that because you passed 7 quizzes with 7, each one took you 3 hours on its own, is doing anything, because it's not. Those quizzes are there to show you the weaknesses so you can actually fix them on a daily basis, get you to practice this every day rather than, Sunday 6 hours in one shot. That's not good. But this, post-test, let's see. Start the test. 22 questions. 22 questions, and it's going to give you instant feedback, right? So you have to solve all 22 questions and hit submit, right? Which, depending on your knowledge, can take anywhere from, I would say, hour and a half to 17 hours, right? And then you will know what are the areas that you have to practice. The next part is my homework closed. What do I do? Problems. Right? And how you do the problems? You go into the study plan. Right underneath quizzes, you can access Calculus 1, Calculus 2, Calculus 3. If you click on all chapters on top, you see all chapters underlined blue now? It gives you all chapters. Now this gives you not just the homework problem that you might have missed, it gives you access to every single problem within that section, that it's available in the entire problem bank. So when I pull problems from quizzes, I have to pull it from here because this is all of the problems that exist. When the homework is created, it has to be pulled from the same database. So this is the boss database that contains everything. And then the homework and the quizzes are subsets of these. So study plan, again, it will not calculate towards your homework grade. It will not calculate towards the quizzes or anything like that. It is for you to go in and practice and learn, because it's far superior to opening the book and going to the book problem, because the book problem doesn't tell you whether it's right or wrong. Right? This will. So go into length of curves and here, right? And then there was a problem loading the page, right? Which is obviously is going to be there because I'm trying to demo this. God damn it. And now there's problem to load everything. So study plan, all chapters. There they are. And wow, each one of these has a video associated with it. So you can learn a lot if you do this stuff right. So.
You said use a calculator? You mean scientific?
Scientific calculator is permitted, and the basic calculator is permitted. I would obviously advise you to have the scientific calculator with E because of the word problem, right? You have to have that K right to the 4 decimal precision, right? 4 significant figures. So that's important. Be careful, guys. Some of these calculators look like scientific calculators and they don't have E on it. There is a TI 30 something version that does not feature E and LN on it. I don't even know why that calculator exists, but it does. And I know because the student walked up to me and said, how do I do E on this calculator? And after 7 hours of looking at that thing, I said, you just don't, because it's nowhere on that calculator. It looks just like that one, but that one has E's, right? Or no?
Yeah.
It has? Okay. Has he? Gold star. Psh. Yeah, stop bragging. All right, so let's take a look at a problem with the arc length where you can enjoy the trick of expanding and then collapsing. So guys, you have homework, you have quizzes, you have study plan, you have the post-test on this. So it's 4 different things to practice. Okay, so let's take a look at So find arc length for function f of x equals 2/3 x to the 3/2 minus 1/2 x to the 1/2 on interval 1 to 9. So we are looking for the arc length. Now, we don't really know how this graph looks like. Well, you can crank all of the Calc1 stuff with increase, decrease, concavities, min, max, and everything else. But we really don't need to, because we know that it just plugs in a formula and just do it, like you would say. So L equals integral from 1 to 9, square root of 1 plus, and now we need the derivative of this squared. Well, 3/2 drops down, cancels 2/3. You have 1/2 there. So x to 1/2 minus 1/4 x to the negative 1/2. Everything squared. Dx. Maybe I should, let me just write the derivative here. So f prime is going to be x to 1/2 and then minus 1/4 x to minus 1/2. All right, so it's time for us to expand this, and once we expand this, we will have to work with the price. So guys, this is one of those, this is the crucial part, right, to get. Integral, square root of 1 plus, and now we are squaring this, so it's just going to be x, and then minus 2 times first times second. Well, x to 1/2, x to a negative 1/2, they go to x to the 0, which is 1, so we just have negative 1/2 there, right, because it's 2 times a times b, right, 2ab. And then we have plus 1/15 x to negative 1. And then we have dx. Don't forget the dx, that's minus 1 per line per problem. I know, so if you have, let's say the question is worth 5 points, but you have 6 lines, you forgot dx, that's technically negative 1 for that question, even though it's right. You forget plus c, that's another minus 1.
Where did you go from minus 3 all the way to the answer?
I approve. Now, these two combine. And we get 1x, comma, plus 1/2 plus 1 over 16 x minus 1 dx. And we have this situation like before. If these three came from here, where these signs match, then the one on the bottom has to collapse into the same thing with a plus. So it's going to be x to one-half plus 1/4 x to the negative 1/2, everything squared, dx. This is where the square root and the square cancel, and all you need to do now is to integrate the x to 1/2 plus 1/4 x to the minus 1/2 dx. Integral of the first one is going to be 2/3 x to the 3/2 plus 1/4 x to the 1/2 times, right, divided by half, same like times 2. Everything computed from 1 to 9. adds 2/3 x to the 3/2 plus 1/2 x to the half, which is the square root of 1 to 9. Great. Plug in 9. That's 3. That's 27. That's 9. 2 over 9. No. 18. So square root is 3. 3 is 27 divided by 3 is 9 times 2, 18. Good. Plus 1/2. So 3/2. And then minus 1. And then minus 1/2. So 3/2 minus 1/2 is 1. That's 19. Minus 2/3. And then 9 times 3, that's 57 minus 2, 55 over 3, I hope.
Why did you write times 2?
What do you mean, why right?
The third line up. Where'd that times 2 come from?
Right by
Oh,
half.
okay, yeah.
Yeah, it's supposed to be when you integrate this 1/2 over here, it's plus 1 divided by n plus 1. So it's going to be divided by 1/2, but dividing by 1/2 is the same as times 2.
All right.
So instead of me writing over 1/2, I wrote times 2. All right, so Matt, you happy? You happy?
What?
Never mind. Forget I even asked.
Wait, no, that wasn't my question. I was asking about you, son.
Oh yeah. No, who asked about this?
I did.
You did?
Yeah.
Are you happy? All right. Now we take a look at the U sub with changing limits, because we can and we should. For that, I'm actually going to go into Calculus 1. This class ends around 10 o'clock, right? We have time.
11:30. Oh, that's the next one. This is like till 11:30.
Yeah, Tuesday it goes till 2:30.
And it was 8:30 in the morning. It was like 1:30, yeah. Yeah, they gave us a lot of breaks. No. That was Calc 1. Calc 1 was easily 5 hours.
All right, guys, so here's a wonderful example. There you go.
method is
What happened?
what method is it?
The only one you can, actually. We're not looking for volume. We just want to solve the integral.
Oh. Fundamental?
Yeah.
With a calculator. Just put it in. Just put it in like the drafting. Oh, you said? What, for what's on top of the E?
Yes. What?
Like 1/3. Yeah, yeah.
You got that too?
Yeah.
E to the negative 1 cubed is plus 1 is 0.
Yeah.
And you can't do it. Or it's 1/3
You
to the
put different lines of
So it's just 1/3
I'm a box.
Oh, it's on that's actually, yeah, right?
I got a
No, but imagine like putting like a slide on the side levels.
Oh, that's mine.
Let's see. Let's see.
No, like if you've already got your
Most T is only
Ciao.
when there's no like.
It's like, yes.
You know what?
well, no, you said that you were or calculating impact.
Yeah.
So you're adding.
I'm just gonna write plus C like everywhere on the page. Is it gonna be like C plus? Is it
Wait, no.
Maybe you got that.
Oh, it's something wrong.
Wouldn't it be minus 1/3? Yeah.
Well, if you carry that, what's the word I'm looking for? Multiply the factor the 1/3.
Okay, so minus 1.
No, I got it. You had it in mother tongue.
I like don't want to take. I want to take linear algebra. So I get my mathematics degree.
Math.
Why are you writing it wrong?
No, because I
Is the answer?
Oh, right, yeah.
You get 7?
Yeah.
No, good, because that would be wrong. You sub, right? Right. What's the U?
The x squared. You already have x squared. One third is outside.
Yeah, I know. It's -1 lurking in here. Just want to see how many of you are writing it in. Okay, so I have x squared. I don't have a 3, so I'll fix that. And I have e to the u du. But then these limits are no good anymore. So we'll use this equation. We use this equation. -1, that's a 0. Because I have -1 cubed plus 1. That's -1 plus 1 is 0. And then I use 2. So 2 cubed plus 1, that's 9. So the new limits in terms of u, and I don't have to go back to x. Done deal.
Oh, that looks the same.
Yeah, I just put it in there.
Why did you do
I don't know why you did that.
If you were to
I did the same thing you did.
Yes.
Funny to me, did the same thing. I can't believe
like
we did
plug
that.
x cubed plus
Somehow
1
it's
into
a hard call.
well, she could do it the regular way.
No, you can't. Yes, I got the same. I forgot to do the 0 to 9. And then I still have the same one.
Because if you didn't do that, this might be like a regular old problem. That this whole problem was to change it.
This
We didn't even do that.
Guys, question.
When you know that you have to change the limits, what's the clue that the limits are going to change?
Well, first of all, you don't have to change the limits if you are planning on going back to x, right? So if you want to integrate this and get this step here, you can replace u x cubed plus 1 and then keep -1 and 2 and then compute with that. You will get this. But I don't like to write that much. So more work. So I swap the limits because in this integral, it's x1 to x2, right, on the x-axis, and then x, everything is in terms of x. Well, in this integral here, everything must be in terms of u, and then u1 and u2. So how do I get u1 and u2? Well, here's the equation that connects x's and u's. If I plug in x1, it's going to spit out u1. So x1 is -1, the bottom limit. So -1, that's this calculation, -1 cubed plus 1 is 0. So for the lower limit of -1 in x, u will be 0. And I did the same thing again for +2 cubed, right? So because these are x's, this is x1 and x2, and I plug them in x's to get u1 and u2. This method is far faster, right? And less calculation. I like it better because I don't have to go back into this, long-winded x expressions, right? The x cubed plus 1. I can just deal with e to the u. I plug in 9 and then e to the 0 is 1. So much faster. Do you have to do it? Nope. You can go. And plus, what do you want to do for an hour and a half on that?
Well, are you giving it the whole class? That's what I'm saying. It's on Tuesday, so we're gonna get how long are we gonna get it?
Exams are geared to be hour and 20 minutes, and then if you, then you can work through the break, through the grace of me, and then after that lectures, yay, 7-2. No, I will not make you do anything. I will do the lecture. You can do whatever you want. It's a 3-hour class. We're going to waste half of it on the exam. The other half we can have fun. We define fun the same way. Any other questions?
Did I write down everything?
The word problems. Word problems in 6-9.
Oh, like the decay problem?
Yeah, we have decay problems and the growth problems.
That's going to be on.
Yeah, pick up one. And then when you get the answer, you either take the derivative of it or you take the limit of it or integral, depending on what the question is asking, right? If it's asking for the rate of change, you're differentiating. The end behavior is the limit to infinity. The accumulation of any kind is the integral, right? What's the rainfall over, 3 months? The integral for those 3 months.
There was something like last you were wondering about. You wrote down. So, like, question 3 is giving us the 2 ranges work.
Yeah.
Everything else that I do, I don't know whether or not two ranges.
Yeah. I did, but I can't vouch for the quality. Yeah. Yeah, you don't.
Well,
It's just,
unfortunately, it's actually part of the requirement.
just haven't seen each other. Yeah, last week.
And also question if I can
Draw them over the razor.
Yeah, I have,
Tell me anything.
I have
We'll definitely do
Draw
five.
them over.
five,
Something else.
8, 9,
You know, I got it.
I mean, you still get a walkbook as long as you
I
get
did.
it right.
If you're going from 0 to 2 or 1 to 2, aren't you
You
gonna
need
get
to have the walkbook.
one fucking
mathematical
close and then
five
it's
class.
off and then another one picks up?
So,
but
that's the
I
problem with
know
walking
that I
out,
can.
is walking out and doesn't show steps, so it's going
So you have to like do a
Mathematical.
thing. You have to like someone on the screen like one of those.
One of those. You got this. I don't worry.
Yeah, like,
Yeah, okay.
But it doesn't, it gives you a link, no, it gives you a link.
I'm here for another 10
Where
minutes.
does it give, where does it, I looked at the solar.
Well,
So I'll
the
just
link is garbage, so it
write
doesn't
down
matter.
Yeah, but all I can find is.
and then I'll just
Yes,
put
that's
them
what
on.
I'm saying.
It's an export.
It's like an hour-long tutorial on how to.
That's
So,
that's
Yeah,
my
no,
line.
I live in that. Yeah, exactly. $1,000 gift
You asked where I go when I go out. I go to Bridgewater.
Any other questions? No? All right, we'll end the stream by stream.
Well,